This is Unit 2, Systems of Equations, and this is the first lesson where we'll be solving systems of equations by graphing. Our objective in this lesson will be to solve a system of equations by graphing. This is the vocabulary for this lesson. Please write down the vocabulary terms, be familiar with them, and there is an example of what a system of equations looks like. Pause the video now to do this. Our first method to solve a system of equation is going to be graphing. So what we need first to find the solution is we need to graph our two equations here. So I'm going to graph the first equation here, 2x plus 4. I'm going to graph it here in red. First of all, remember your starting point is your y-intercept. So that is my starting point. So I'm going to draw a point right there at 4 on the y-axis, and then I'm going to use my slope. My slope is 2 over 1. What that tells me is I go up 2 and over 1. So this is my second point here. And so this is what this line should look like. Now I'm going to graph my second equation in blue. My y-intercept on this one is 2, so my starting point is a positive 2. And then I'm going to use my slope. There's no number in front of my x, so that tells me my slope is 1. And to make it a fraction, I put it over 1, so that would be up 1 over 1. So this line looks like this. All right, now I'm looking. My solution is the point where these two lines cross. So this is the ordered pair, -2, 0. So the point of intersection, that's my solution to the system, is -2, 0. Now I'm going to check to see if my answer is correct. I'm going to plug in 0 for y and -2 for x. When I simplify that, I get 0 equals 0. 0 does equal 0, so that solution works on that equation. Now I'm going to plug in 0 for y, -2 for x, and I get 0 equals 0 over here, so it satisfies that equation too. So my solution is -2, 0. All right, now we're going to do a word problem. Here's our problem. We have a satellite radio service. They charge $10 per month plus an activation fee of $20. You have a second service that charges $11 per month plus an activation fee of $15. It wants to know for what number of months is the cost of either service the same? When is the cost equal? How many months does it take for them to be equal? So what we're doing is we're relating the total cost. It is always stands for equal in math, the monthly charge times the number of months plus the activation fee, sorry. So we let C be our total cost, and we're letting N be our number of months. All right, for the first service, you'll notice from reading the problem that it says it charges $10 per month. So that's $10 times N plus our initial fee of $20. All right, and our service 2, the total cost is going to be equal to $11 per month plus an activation fee of $15. All right, now when we want to know what variable, if you graph it, is going to be on the x-axis. That's always your independent variable. Your cost depends on the number of months. So your N is your independent variable. Your cost depends on how many months. So your C is your dependent variable. And what will the intersection of the graphs tell you? It will tell you when the cost of either service, what month the cost of either service is the same. So it's when the cost of service is the same. All right, these are our two equations at the top, and we're going to graph those on the coordinate plane. First of all, we're going to graph the c equals 10n plus 20. So our starting point is 20, and then we're going to use our slope, which is 10 over 1, to graph some few more points. So it's going to go up 10 over 1. It's going to go straight through all these corners right here. So that's what my graph of that one looks like. Now the graph of my c equals 11n plus 15. The starting point is 15. And from there I'm going to use my slope up 11 and over 1. So I'm going to go up from 15 to 26 and over 1. Then I'm going to go from 26 up 11 more to about 37 and over 1. Then I'm going to go up about 11 more, and I'm going to go up to about 38 and over 1. 48, sorry, and over 1. Then I'm going to go up to about 59 and over 1. And then I'm going to go up to 59, 70, and over 1. And 11 and over 1. And this is what this graph should look like. So if you'll notice here, my point of intersection is right here at this in the ordered pair for our is. I go over 5, and then I go up to 70. So my answer is C. So in month 5, the total cost will be the same. Alright, this is a lesson check here. I want you to follow the steps here, 25 through 28, and see if you can graph and solve this system of equations by yourself. So stop the video, try to work out these problems, and expect to see something about this tomorrow. Alright, this is a concept summary, and this basically just tells you how to read the graph and tell how many solutions there is to a system of equation based on the graph. You will have one solution if your lines intersect at one point, and these lines always have different slopes. You will have infinitely many solutions if when you graph them, the lines are the same. They're going to have the same slope and the same y-intercept when you put them in slope-intercept form. And you will have no solution if your lines are parallel. If they're parallel, that means they have the same slope but a different y-intercept. So you should pause the video and write this information down. Alright, now we're going to apply the information from that concept summary to determine how many solutions are to a system of equation by looking at the equations. We're going to compare the slope and the y-intercept. Our first equation here has a slope of -1. And our second equation has a slope of -1. So they have same slope. And now we're going to compare our y-intercept. We have, this one has a y of -3. The other one has a y of +5. So same slope, different y-intercept. That means the lines have to be parallel. And if the lines are parallel, that means there is no solution. And the only choice we have here is B. It's the only one with parallel lines. All right, now we're going to classify a system without graphing. We're going to classify it by how many solutions it can have. It can have 0, 1, or infinitely many. So first thing we need to do is to put these equations in slope-intercept form because we've got to compare their slopes and their y-intercepts. All right, so first thing we have to do is we have to get it in our slope-intercept form, which is y equals mx plus b. So I need y by itself. So I have got to move this x over to the other side. When I do that, my equation becomes y equals a positive 3x because when it shows up on the opposite side, it has the opposite sign. So this is my equation here in slope-intercept form. Now my second equation. Same thing, I've got to get y by itself. I've got to get it in slope-intercept form. So I have to move my x over to the other side. When it gets over to the other side, I now have a -x plus 1. But now I only want a y, and I have a negative 1/3 in that y. So I have got to multiply both sides by -3. Alright, my -3 causes this to cancel out, and I'm left with just y. So, and I'm going to distribute my -3. -3 times -x is a positive 3x, and -3 times 1 is a -3. So my other equation in slope-intercept form is y equals 3x minus 3. So the slope of my first equation is 3, and the slope of my second equation is 3. So my slopes are the same. So I know if I have the same slope, I don't have one solution. My y-intercept in the first equation is 4. My y-intercept in the second equation is -3. So the slopes of my lines are equal, and the y-intercepts are different. So if slopes are equal, y-intercepts are different, that means I have two parallel lines, and I have 0 solutions. Alright, you're to complete this lesson check on your own. Refer back to the concept summary that showed you how to interpret the graph on the number of solutions you can have, and expect to see something about this tomorrow.